this video I'd like to talk about the equation of time. Now, the equation of time is not an equation. The equation of time is actually a number of minutes. It can be positive or negative, and it depends on what day in the year you are. For example, today the equation of time is plus 7 minutes. In a couple of months' time the equation of time might be minus 10 minutes, or the equation of time might be 0. It's a number of minutes. I find what helps me to understand it, it's how far ahead what your sundial says compared to what your clock says. So if your sundial says the time is 15 minutes past 2, and you look at your clock and your clock says it's 5 minutes past 2, then the equation of time is plus 10 minutes. If your sundial says it's 3 o'clock and your clock says it's 7 minutes past 3, then the equation of time is minus 7 minutes. So the equation of time is this, the apparent solar time. The apparent solar time is what the time appears to be according to a sundial, the apparent solar time, minus the mean solar time. And your mean solar time, well, if you live in Greenwich, your mean solar time is what your clock says. If you live in Greenwich, then your mean solar time is Greenwich Mean Time. If you live somewhere else where your longitude isn't 0, we'll worry about that in another video. In this video, we'll just say that your longitude is 0. Imagine you live in Greenwich, and so your mean solar time is Greenwich Mean Time. If you go out tomorrow morning, very, very early, and if it's not cloudy, then quite early in the morning you'll notice something happening over in the east. You'll notice a big yellow ball will appear in the sky, the sun, and that's sunrise somewhere over in the east. And then throughout the course of the day, the sun will rise, get higher and higher in the sky. About the middle of the day, the sun will culminate. This is a word that we'll be using a lot in GCSE astronomy. To culminate means to reach its highest point in the sky. Where I live in Middlesbrough, even in the middle of summer, the highest point in the sky is about there somewhere. If you live in the tropics, then it's possible for the sun to be at your zenith. But anyway, the sun reaches its highest point about midday. Then after midday, the sun gets lower in the sky, and then the sun disappears below the horizon, and that's sunset. So sunrise, around midday it culminates, and then near the end of the day, at the end of the day or another day older, right at the end of the day it sets, and that's sunset. So at what time does the sun culminate? So there's the sun culminating. Well, one thing I can say is that when the sun is culminating, my apparent solar time is that. It's noon. That's my apparent solar time. Again, we're living in Greenwich. We know now that that could be quite different from my mean solar time by as much as about 15 minutes. So the sun, according to my clock, could culminate quite soon before that or quite soon after that. Now, why does it do that? And the reason is to do with the orbit of the Earth around the Sun the fact that the orbit of the Earth around the Sun isn't circular, it's elliptical, and another reason is because the Earth is tilted. And what you will find is that in the middle of the summer, the Sun will culminate around here somewhere, or it might culminate around there, or it might, and then as the year goes on, in March, it will culminate around here, and then the year goes on and we go to winter. In December, the Sun will culminate around here, and then we come back again, and the Sun culminates higher and higher and higher. So on June the 21st, the Sun culminates around here. On December the 21st, the Sun culminates around here. Then we have January, February, March, the Sun culminates around here. April, May, June, July, August, September, and then December, so that's December the 21st, March the 21st, when it's on its way up, September the 21st, when it's on its way down again. On this particular day, when the Sun is highest in the sky, culminating, that's called the summer solstice, and that is the longest day of the year. If we say a day is the time between sunrise and sunset, then that is the longest day of the year, the summer solstice. Down here, this is going to be the shortest day of the year. If a day is the time between sunrise and sunset, this is the shortest day of the year, and that is the winter solstice, which is usually on December the 21st. Here, on March the 21st and September the 21st, daylight and night time are equal, and this is our equinox. We have the spring equinox, otherwise known as the vernal equinox, which is on March the 21st, and then as it comes down, this is our autumnal equinox, our autumn equinox. So, summer solstice, autumn equinox, winter solstice, spring equinox. This shape, you might be interested to know, is called an analemma, this figure 8 shape. Let's look at this equation. In the exam, you'll be given this equation, although I do suggest you learn it. I think if you haven't learnt it, then you won't understand it as well as you can. But let's have a look. The equation of time, I said, was a number of minutes, either plus or minus. The apparent solar time is what the time appears to be according to your sundial, the apparent solar time, minus the mean solar time, which, if you live in Greenwich, the mean solar time is Greenwich Mean Time, and that's the average solar time. So throughout the year, when you compare the two, the sundial could be ahead or it could be behind within plus or minus 15 minutes. This is the average, this is the mean solar time. There is an idea of a mean sun as in an average sun, the average sun throughout the year. So the equation of time is how far ahead the sundial reading is. Let's look at a couple of examples quickly. If my sundial says it's 10:15 and my clock says it's 10:05, then the equation of time is, okay, well, the sundial is 10 minutes ahead of the clock, so plus 10 minutes. Okay, the apparent solar time minus the mean solar time is plus 10 minutes. Number 2, my sundial says it's 9:30. My clock in Greenwich, because I live in Greenwich, I don't, but there you go, 9:37. So how far ahead is the sundial? Well, it's not ahead, it's behind. So the equation of time is negative, and it's minus 7 minutes. Let's finish off with some key points. First of all, the equation of time is a number of minutes between plus and minus 15 minutes or so. The equation of time is a number of minutes, it's not an equation. It is how far ahead a sundial is compared to a clock. That is if you live in Greenwich. We'll worry about other places later. And the equation of time, well, apparent solar time and mean solar time, why are they different? 2 reasons: because the Earth's orbit is elliptical as it goes around the Sun, and secondly, because the Earth spins on a tilted axis of about 23.5 degrees. And for these reasons, when the Sun culminates throughout the year, when local noon happens throughout the year, varies quite a bit. Hope you enjoyed the video. If you press subscribe, about there somewhere, subscribe, then you'll get a notification when the next one comes out. Have fun, watch the skies.